very much. Well, let me start with thank you to Microsoft Sweden for giving me the opportunity to complete my Scandinavian speaking experience, because I've been speaking in Iceland twice, half a dozen times each in Denmark and Finland, and over a dozen times in Norway. I've not been once to Sweden. So thank you very much for inviting me this time. That's wonderful. So now I can basically check off Scandinavia, and I'm still missing parts of old Yugoslavia, and I think then I have Europe complete. So wonderful for that. Service Bus. I started on this team about 5 years ago when it was 2 people, and I joined as the third. And those 2 people have meanwhile left for other opportunities, so I'm the oldest guy in town. And I'm going to tell you what we've done in the last 5 years. We've shipped this product commercially in January 2010. The features that I'm going to talk about today are all shipping available. You can use them today. And towards the end of the talk, or weaved in, when I say future, I'm going to mention some things that we're going to do in the future, but mostly all those things are here today and you can use them, and they are used by customers in production. So the session objective is, why did we build it? And what are the customer scenarios that they're applicable to? So I'm going to start with a number of customer scenarios, reasons why Service Bus is relevant, why we think you should take a look at it for your scenario, specifically when you're building cloud applications. And then I'm going to introduce you to the namespace, the relay, and messaging. So this is kind of the broad mission statement that we have, pieces that we have in Service Bus. We have connectivity. I'm going to talk about that, and I'm going to talk about the Service Bus relay. And to show you that, I'm going to expose from this network a publicly accessible web service from this network. I didn't talk to anybody beforehand, so I'm going to pull the rabbit out of the hat, and I'm going to create a web service that you can reach from the public, that you can reach from the outside world using the relay. We're going to talk about messaging. We're going to talk about naming, discovery with the service registry, and then integration, routing, coordination, transformation are all features that are coming, but they're delivered as part of BizTalk that are becoming extensions for Service Bus. So the BizTalk team is a team that we closely collaborate with, and the BizTalk team owns and continues to own the EDI and EAI story. And they currently also have a CTP in the labs environment that we have, the playground environment that we have, where they're trying out how EDI and EAI work in the cloud. So we're working closely with them, and they kind of own the box over there. Let's start with why we use Service Bus, what Service Bus is good for, what is motivating all that work, and what is Service Bus after all. One of the important things in the Windows Azure platform overall is when we're thinking about customer scenarios, we're thinking about workloads. We're thinking about the applications that you build. And we know that you have applications, if you're an enterprise, or if you supply enterprises with applications, that there are applications that run, obviously, in the enterprise's own data center, or in a data center that's being run for the enterprise. And when we mean data center, the data center might very well be a computer under a desk, or maybe some server room, or maybe a proper data center facility, all depending on how big that business is. But there is stuff out there. What we offer you as Microsoft, and what also our colleagues at Amazon offer you, and Google offer you, and all those things, is effectively we have a data center. We believe we can run that fairly efficiently, and we believe that we can run that fairly cheap, probably cheaper than you can, and probably procedurally better than you can or that other people can. So that's our offer that we make with Windows Azure. However, you're going to have all these cloud applications that you're building in the future. They will have to talk to on-premises assets, because you have invested in the machines, you have invested in the software, it runs on your site, it needs to amortize, you need to run it for 5 years so you can write it off, blah, blah, all those things. including also there are plenty of assets which you will not move into the cloud for the foreseeable future because there's regulation, you have trust issues, there's all kinds of reasons for not moving into the cloud. Also, there are plenty of scenarios where you cannot move to the cloud at all because your workloads need to be where the customer is. Think of an ATM, a check-in kiosk at an airport, a vending machine, all those assets that are also computers that are sitting out there in the world that you need to go and integrate with. So even if you're building a fresh cloud solution, and the fresh cloud solution were something that, let's say you have a vending machine for where you're renting out DVDs. So you build something like this. You build a brand new thing and you want to rent out DVDs through vending machines. There's several companies actually in the US that do that. How do you connect those? Right? They're sitting somewhere out in the field. They're sitting on some network. How do you connect to those? How do you organize them? So that's one of the reasons why we build Service Bus. Cloud-hosted, reliable, asynchronous messaging for one-way connectivity, for buffered messaging. We have our cloud-based relay, so we have NAT and firewall traversal. If the on-premise assets are sitting behind a firewall in NAT, how can you reach them? A service registry to organize those services, and an integration with the access control service to secure access to them. So that's the overarching story, is about hybrid applications. Hybrid applications meaning applications, workloads, distributed architectures, where parts of the application run somewhere on premises, meaning in an environment that you own and manage, and some parts run in a cloud environment, parts that someone else runs, and you partially manage or you don't manage at all. So spanning those kinds of environments, one is in the cloud, one is something that sits somewhere on premises, not in the cloud, not inside of a Microsoft data center. Now you'll say, hey, that I can very easily do with a VPN, and that's true. There are scenarios where that gets a little more complicated. Let's say you're building a SaaS solution. In many larger enterprises, it's very common to have a marketplace. A marketplace where you can go as an employee and buy a new pen or buy a stack of paper or buy a new computer. So the procurement department in the enterprise sets up this marketplace, and that's integrated with a number of vendors where you can order those things from. But there's governed prices, and there's a single portal, there's a single catalog where you have those things. And every enterprise builds one of those things. Let's assume you were building one of those as a SaaS solution. So you're seizing the opportunity and say, I want to sell this thing to Microsoft instead of them running it themselves. Well, it's hard to compete with a software company, but let's say you do this for another company. Now you have integration that you need to do with all kinds of different vendors. You can't move everybody into the same VPN unless the vendors were willing to do that. If you're a very large company like Microsoft, you can pull everybody into the same extranet. But if you're a smaller company, then that's going to be a very difficult sell. Let's imagine you're building a solution like, a CRM system. Microsoft Dynamics CRM, for instance, runs CRM online, and that's a SaaS solution. It's multi-tenant, runs up in the cloud. And they also have on-premises versions of CRM, obviously, and they can actually replicate and synchronize between them. So they have an on-premises version that's something that's run in the office, and then they have Dynamics CRM online, and that sits up in the cloud as a multi-tenant environment. They need to be able to reach from online CRM into your instance that sits in your server, and they're actually doing that through the relay. They're doing that through Service Bus. So when you have on-premises systems and you want to connect them up to a multi-tenant, to a SaaS application, then you need to have some communication link. And that becomes fairly complicated if you were doing that with traditional means, if you were doing that with a VPN solution. Because VPN means, ultimately, that you're creating a single trust zone between all those parties. If you're doing this with a solution where you have a single owner, and the owner owns all the branches, then that's something that's tenable. If you're having a more diverse environment, that gets more complicated. Let's take a look at a more complicated environment, like this. Similar picture than before. You have a central solution. You have, let's say you have a commerce site. This picture is a pizza chain. So they're selling pizzas to you. And if you imagine a large country, like the United States, but you also have those cases here. Let's say this is Frank's Pizza. And Frank's Pizza is a large national pizza chain. The way they're going to run this is mostly as a franchise organization, which means Frank's Pizza is really a central marketing organization and central procurement organization. And all the pizza restaurants or delivery centers, baking delivery centers, are all partners that are independently run companies. So as you sign up for the franchise, you're getting some software from them that you run. I mean, you get all kinds of equipment, but you also get some software for them that you run in your restaurant. They make the website, and they have a menu, and the menu is harmonized across all franchise partners as part of your franchise story. And then someone comes in and says, I want to have some pizza, and they enter their postcode, and then the website selects a pizza restaurant for them and sends the respective restaurant that order. So how do you do that path? Because that restaurant is a restaurant, it's not an IT shop. So it sits on some kind of internet connection, whatever is available there. In several parts of the world, including several parts in America, one of the options that you have here, for instance, is being connected through WiMAX. That's one of the broadband options you have in the US. WiMAX means you're behind a NAT. You don't have a public IP address at all. So you have various connectivity options. Some of those shops obviously are within big shopping malls where you get network as part of being in the shopping mall, but again, you're sitting behind NAT. So how do you make it possible that that commerce site can actually go and send messages to those partners and actually go and do a query to an inquiry? Because what they're doing meanwhile in those websites is they allow you to check your order, and they allow you to actually check how many minutes is it going to be until you have your pizza. They're actually very accurate these days, at least in the US. So a chain, I will not name him, that I'm using sometimes, they're actually down to the minute. I can go and ask the website, in 17 minutes my pizza is going to be there, and they're so good that they're within a 3-minute window the guy stands in front of my door. So that's it's fairly good. They also want from the back side, on the business side, they want to have insight into the partners for marketing. So let's say they run a radio ad, or they run a big TV ad. In America, the #1 day for pizza stores is Super Bowl. They sell twice the pizza on Super Bowl day than they sell on any regular day. When the ad runs, and they run the ads in certain times before Super Bowl, I've had discussions obviously with multiple of those vendors, and the story is always the same. They want to know how that ad is actually, what the ad is doing and how the ad is doing. And of course they're seeing that as traffic that comes in here, but then also they have people that call in directly, etc. So they want to have a clear picture of how the marketing campaign is going. So on the back plane, they're actually able to query into those partner systems and do a fan-out query and collect all the data back. So that's an interesting story here. How do you reach into all those things, but how do you do this without massively manipulating the network? One of our customers that we've talked through this case with used to run a VPN. And now the reality is all these pizza restaurants are run by 20-year-old people, right? Overseeing 17-year-old people. You can imagine what's on those PCs. Everything. So what they ended up with is they ended up with defending everybody from everybody else because they had the most worm and virus infested network you can imagine. Because it was one big trust zone. So they got rid of the VPN, which was enormously expensive, and they're just setting that up on Service Bus, and they're happy. Another case that we're seeing more often is, and that's driven by consumerization of IT and people bringing their own machines to work, is these application client services, these gateways that people are building in the cloud, where they have an on-premises system, existing applications, and now people say, hey, I want to have a solution on my mobile device. And when you look at what the mobile devices allow you to do, that's not a lot. What we're in enterprise environments used to is you build your notebook solution, and then you have a VPN, and then you have two-factor authentication, and blah, 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 and smart card, and retina scan, and whatever else. You can forget all this on the iPad. You can forget all this on a phone, on Android. You can have point solutions, but there's really, when people bring their own devices, a lot of the things that you think are enterprise are no longer there. And setting up a VPN and then multiple VPNs and then a third, a fourth, a fifth VPN, that's something that's simply not tenable. So how do you deal with that? So we have several cases. They're all following, they're figuring out the same architecture. So we see this kind of in parallel developing. People are building the following thing. They're having an on-premises system, and their customers are running on-premises systems, and typically they run these on-premises systems with no hope or little hope of moving them into the cloud. Think of tax advisors, lawyers, medical field, all these cases. That data is not going to go anywhere. It's sitting on the premises, in the doctor's clinic, in the law firm, in the tax advisor firm. And so now they're building, and we're seeing that as an emerging offer, they're building these beautiful applications for the iPad or for, hopefully for Windows 8 in the future. And they're building these application gateways that reach into the client, into the LOB app on premises, get a data package up, and then prepare that data package with a web service so that the application can actually go and query it and present it in the right way. So reach down into the on-premises app using the relay or using messaging of Service Bus, and then present that up in Windows Azure, and then let the client application talk to it. So use us as a security tunnel to go in and reach into that environment. So we're seeing that as a pattern emerging. We're going to add, so in addition to this, we're going to add a number of client services. We've talked about that at the Build conference, or I've talked about that at the Build conference, where we will allow to target not only the application when it's alive, but also the application when it's tombstoned or not active by using push notifications. So we're currently building out capabilities inside a Service Bus to target the push notification systems for Windows 8, Windows Phone, iOS, and Android. That's going to appear over the course of the next year as a capability. We call this notification topics. And so that's one of the things that we've announced at Build that we're working on that. And you're going to see that showing up in the course of the year for Windows 8 first. Which leads us to completely federated solutions that we're also seeing. And a ticketing site is a good example of that. You have a local ticketing solution, which sits in the venue, and this is completely autonomous. Like local database, local terminals, everything is local. Because if you have 500 people in front of your box office and you're selling tickets and the internet goes down, you don't want to stop selling tickets if the concert starts in 5 minutes. So that would be fairly stupid. But if the Rolling Stones come to town and you're selling, a stadium of 50,000 tickets, and you want to sell that in 3 minutes because that's how fast it sells, then you need to have capacity, ample capacity in the cloud to go do this, and you can't do that with the on-premises system. So you're going to have a large-scale version of this sit in the cloud, which you can expand and contract as you need it to. So a friend of mine in New Zealand built that for the largest ticketing agency in New Zealand and Australia based on Windows Azure. And they're actually taking an approach of effectively they can go and scale this up and down per concert or per venue. And then they have these backing systems which are sitting on the venue where they can do also the sales. And they replicate the data between those systems, so the box office replicates with the ticketing site. So they have independent systems that are federating with each other, that are replicating data with each other, and they do that through messaging. And then lastly, a scenario, we have things that we're seeing, large-scale eventing, devices. Where devices are not screens of this sort. When you think of a tablet, the tablet is a larger screen, this is a smaller screen, they're all screens. Here we don't mean devices that are screens, but we mean devices that are embedded devices. I'll give you an example. Things like this. This is an air conditioning. It doesn't look like one, but it is one. The fan is missing. But it's got all the control units to do this. And so how do you hook up those things to Service Bus? And why would you want to? Well, let's imagine you are, so this is Seattle, so probably Seattle is not the best city to show this with. But let's imagine for a moment this were San Diego. And San Diego is pretty hot in the summer. And everybody's running their air conditioning. And California, the entire south of the United States, has continuous problems with their power grid. Because it's probably not well engineered. But if it gets really hot, everybody's running their air conditioning, and air conditioning is something you run on power. Wouldn't it be nice if the energy company, if it sees that the grid is about to fail, could bump up everybody's temperature by 10 degrees, and basically override everybody's air conditioning setting? Because that would obviously solve the problem. Right? Everybody feels a little less comfortable, but the power grid is not out. The alternative is the power grid is out, and then everybody's going to heat up to the max. How would you do that? So the case here is about smart grid. It's similar, where you have a case where this is something that is also that people fear. Let's say people buy electric cars, start buying electric cars because they're cheaper, or because they're heavily subsidized. What happens to the power grid is the power grid suddenly becomes the fuel station for everybody. That's something that the energy companies are actually worried about. So what they want to do is they want to regulate this over price. Regulating this over price means not that you do this at night, but that only select people do this at night at certain time windows. So what you'll do is to deal with that is you need to go and effectively go and shine a cone of low energy prices over a region, right, over the period of the night, so that devices kick in and then start the charging and stop charging. And you do this either on a per region basis, or you do this kind of scattered throughout, like a checkerboard, throughout the region, so you can actually manage this. But for that, you need to be able to control these smart devices, which can actually take the pricing. And then you also need to deal with this at a large scale, right? This is the Seattle metro area, and there's a million people here. So let's say 500,000 households. So you need to do that at a scale of 500,000. You need to do this quickly. How do you hook up 500,000? How do you hook up a million? How do you hook up 5 million, 10 million? So that's another mission that we have, kind of long term, to deal with those problems. And again, it's no accident that I'm carrying an air conditioning around, because we're actively working on those problems. So much for what the mission is. So the mission is about connectivity, creating federating applications. That's what Service Bus is about. You have workloads in the cloud, you have workloads on premises, you have workloads on premises, and you want to interconnect them. How does that work? First, I'm going to talk about organization. How do we organize the data? How do we organize our system? So I have For that, I have a namespace. The namespace is visible. I'm going to show you that in the browser. Here I have clemensv.servicebus.windows.net. There's something already in that namespace. /us, there's a number of topics and queues that are sitting in there. I could go to the portal and show you this. I'm going to launch the portal, but I'm going to go back to the slides because that's going to take a moment to load. So we're going to wait there for that. We're going to, well, 1 second. Let's not be dumb. So, hello. Yes. So, 1 moment. Here's my service bus. Here we are. Now it's loading my data. This is how you get into the portal. This is the area where you find service bus and where you find all the namespaces. A namespace is very much like a site in IIS or like a site in Apache. It's a scope in which you can map services. So if you continue with the notion of IIS, in IIS you can create virtual directories and you map them into a common structure. It's usually backed by a directory, but you can go and effectively create an arbitrary tree by just mapping directories, virtual directories into that tree. So think about the service bus namespace in exactly the same way. The service bus namespace gives you a way to effectively create an arbitrary taxonomy for services and hang services, relay endpoints, or hang queues or topics at the leaves of that structure. So here I have it fairly abstract, foo and bar, but you can make it dependent on a system, a region, whatever your primary pivot is to organize your services. You get an Atom feed at the root. You already saw that feed. And you can manage with a REST protocol. We're going to extend that. We're going to make it more OData than it is right now. But it's based on Atom, and then OData sits on top of Atom, so that's a natural extension for us. And all the names that you can imagine already exist in that structure. It's infinite depth. You have 32 segments, but that makes it almost infinite. And whenever you put an entity in here, the entity owns the rest of that namespace. So inside of that, so here I have a number of my namespaces. Let's go to this one. So you have a number of queues here, and have at the root the issue tracking queue, my queue, and then I have, this is the reason why US shows up here, because I have for practically each US state I have a queue. So that's a flat view that we also offer. For the API, you can also have there's a resource-oriented view, and then there's a hierarchy-oriented view over the registry. I show you this in here because in the browser I can't supply a token to actually get that full view, so that's why I'm showing you that here. I can make the endpoints. Let's go back here. Let's get to the right one. So the endpoints are either private, which means I need to supply a token to see them, to enumerate all of them, a token that I acquire from ACS, and that's part of the SDK, from the access control service, and then supply that here, and then I can go and programmatically enumerate all those things. Or I can choose to make them public, and then they show up without supplying a token. So I show you we're going to show you that in a moment later in detail, this one. So I'm starting a service now, and I'm hanging on this network. So here's now a service. I elected to make that service now publicly discoverable, which means now that shows up, and now I can go and see that service in the service registry. So that gives me a way to kind of publicly discover all the things that are there. Why is that useful? Because if you have a structure that you choose in here where you have multiple, let's say you have multiple branches of a business, and you have a server in each business, and you want to enumerate who's online, who's not online, you can do that through the service registry. You can go and project services in, and the registry allows you to discover who's online, who's not online, who's available, etc., etc. So it's also it gives you also a presence function with that. So that's the namespace. So the namespace is the most foundational organizational principle we give you with Service Bus. It's a way to go and project services into a common surface. The services can be from anywhere. So what you have here is I have a number in my namespace now. I have a number of services which are sitting inside the data center, right? All these queues. And I have a service that sits in Örebro, in Sweden, and that's projecting into that same namespace. And I could go and have multiple services from multiple places around the world, and they're all projecting into the same space. So when you think about that, if you have today 5 services in 5 branches, you're managing 5 host names, 5 different environments, 5 different things. And here, they all come together in a single organizational fabric. The relay is the service, is powering the service that I'm just showing you. So what does the relay do for you? The relay allows you to project any endpoint, any web service into this fabric. We're listening on your behalf for messages, and we send them down into that machine. We're taking an existing WCF service, and we're remoting that for you. We have, for that, a WCF programming model. And there's a number of familiar bindings, the web HTTP binding, basic HTTP binding, and we have the corresponding relay bindings. They're functionally exactly equivalent, and you can go and swap them out and use them instead of the standard binding. So instead of listening on the local machine, you're now listening on the relay. To show this, so this is, I'm going to show you how this works, but I'm going to show you actually in reality how this works. So I have this code here, or this application. Let's go and mark this address. And let's go and take this, put this into the browser. Let's see what happens. We get a picture. This is the Albuquerque crew of Microsoft. They're all very rich people now, even though they don't look like it. This is Bill. This is Paul Allen, proud owner of the Seattle Seahawks and 4 other professional sports teams. And he has so much, and he owns half of Seattle and all those things. Bill is rescuing the world in a wonderful ways, killing malaria, and all the other guys are probably off on the beach having their fun. So this is a public IP. This is a public address. That picture comes from this machine. So this is what this does. See there, someone was quick enough, Clemens V, right? He has the picture. That comes from here, from this box. I did not manipulate this network. I didn't talk to anybody. We can even make it more daring. I could go and disconnect and do it on the wireless network, but unfortunately we don't have 1.5 hours, but we only have 1 hour, so I need to rush. Otherwise, I would do some more stunts. But I can probably do that later today. So I'm just exposing that on this network. Proof? Let me kill that app. Now it's gone. Nothing. In fact, now when I hit this in a fresh window, now I'm getting a feed again, because now I'm hitting it's an infinite nested hierarchy of feeds, and now I'm getting that feed again because the service is gone, and so that's now a place that's reserved in the registry. So I just made that service appear from my machine in the public. Black magic. Firewall traversal. I don't even know how many nets I'm behind. Firewall traversal. All the things are automatic with here. So how does the code look? It's a normal WCF service. It's a web it's using the web programming model here. So it's web get. That's the contract. Get image returns a stream. The service is as you would probably expect. It has a memory stream built on this the cached image here. Saves it to the stream. Sets the stream position to 0, sets on the web operation context, the outgoing response type to image JPEG, as you would expect from the REST programming model. This is not using web API just yet, and returns the stream, and we're done. The magic, all the magic, sits in not in the host, but really in the config And if you're familiar with WCF a little bit, you'll notice that the binding we use here is not the web HTTP binding, but the web HTTP relay binding. That's really the only difference. We have several customers. We have one customer that's they're proudly telling that story. It's an airline in the UK, and they have done they wanted to do a proof of concept of taking a number of the backend services that they run in their data center and pull them up and use us as an external DMZ. It took them 20 minutes to do this, to basically just go and rewire their application and add these endpoints through the relay. Took them 20 minutes, they went into production with that. And then they did a cost study of how much it would cost them to actually do this on their own infrastructure and to pull these endpoints up onto the external edge. Thousands of pounds. So they said, not worth it, we're going to go with Service Bus. So we're actually a cheaper way to expose internal services for them than them doing it themselves, because it really is just a change of the settings. It's for that to work, we do the following thing. Once you start the receiver, what we do is we register that receiver, that endpoint, with Service Bus at that name. That's a one-way channel. Well, it's a one-way communication channel in the sense that there's only a one-way that the payloads can flow this way. And so what we're doing is we're registering here a name, and with that name you also specify what kind of transport that is. So it's either TCP or HTTP or HTTPS. And we maintain that socket. So if I go and so we can go, let me just show that to you. So what I mean with maintain that socket is the following. So here's my service. We still have it here. Well, it gets IE gets confused if you change okay. So now I pulled the network cable. Right. So I no longer have network. Let's make sure that I really don't have any network. So let's go and take this. Let's go and disconnect that puppy too. No more network. Let's put the network back in. Give it a moment. There it is again. So we're being as aggressive as we can possibly be. If we see if the network is coming and going, we're as aggressive as we can be about reestablishing that connection. The client, now a sender comes in. Sender also is an HTTP GET request, and it shows up at any part in the system. We have a typical stamp of Service Bus has 32 front-end nodes. So it lands in one of those via load balancing. Then, so the request comes in, and now we want to establish a keep alive socket or a TCP connection between those two parties. Now this lands on a different node than the original request is on, or the client is parked here. So what we need to tell the receiver is to rendezvous with that existing party. So we send a control message down to this guy that comes up and rendezvous, and now we've established this link between those two parties, and that's how it works. So the receiver makes two outbound connections, one control connection that we maintain, and one kind of per session connection that we that's being maintained for that respective set of, for the keep alive socket for HTTP or for NetTCP. So there's nothing magic that we do. It's just outbound requests. There's two ways how we do this. One is through ports 9351 and 9352. 9351 for this and 9352 for that. If those are closed, so if they're not open, and that's actually the case in this building. So on the guest network here, they are only permitting HTTP traffic to go out. So if that happens, what we'll do is we detect that for the relay, we actually detect that situation, and then we're using HTTP. And then what we're doing is we're creating a long post, an upload, and a long get, a download. We're bundling them together. It's pure HTTP port 80. We're bundling them together. We're overlaying that with SSL ourselves. And then we're taking that bundle, we're plugging it under the TCP infrastructure and just make it look like TCP. And then we're using that as a tunnel. So we have a 2-socket HTTP tunnel that we run then through that infrastructure using HTTP 1.1 chunking. And that works just fine. In the future, as soon as Windows Server 2012 shows up in our data center, and with a little bit of lead time, that's probably going to cost us another 3 months, we're also going to add a WebSocket transport here. So that's what the relay does. The relay allows you to take effectively any workload, no matter where it is, and expose that as a publicly accessible web service. I'm going to talk about security in a little while. Messaging. So this was all about request response or duplex traffic directly connected between the client and the service. Sometimes you want to have it disconnected, and that's what messaging is for. So the relay gives you ways to go from the sender to a receiver straight through, and you get immediate feedback, request response, and you also get back pressure. Back pressure meaning if the receiver can't receive fast enough, it's busy, it's getting a message, doing work, and then responding to you. Well, if you try to send more messages, those messages will back pressure as they do through TCP, and the client will have to wait. If you have a broker in the middle, well, the broker has a buffer, has a queue, for instance, which means you can keep sending, and then the receiver gets the data out, it pulls out as it finds time, and that also gives us the opportunity to do querying and filtering over that incoming data stream. So the difference here is one of push versus pull. In the push model, you have the intermediary, you have the relay kind of pushing the data through. The senders create stress on the receiver. In the brokered model, you have a sender. The sender drives data into the broker, and the broker then gives the messages to the receiver as they ask for it. In our broker, there's 3 ways to pull. Well, 2 ways to pull, and one is decoration. The first one is receive and delete. That's the typical thing how I think about a queue. You walk up to the broker, you say, I want to have a message. You get the message automatically goes away. The problem is, if you have the message and now you fumble it, you fail, the message is gone. While that's faster, that's not as reliable. So the other mode is peak lock, where you get the message and hold a lock on it. The lock is time-bombed. So there's a duration from 2 minutes, or you can make it shorter, you can make it longer, up to 5 minutes. And then you work on the message, and if you can complete working on the message, you tell the broker, complete, thank you very much, and then the message goes away. Or you tell the broker to abandon, or you just completely walk away. If you say abandon, the message immediately shows up again, someone else can take it. Or if you just walk away, then after the timeout expires, the message shows up back in the broker. Which means you take a message, you crash, the message comes back on the broker, and someone else can go and take it. So this is the more reliable option. It has 2 round trips, so it's slightly more expensive, but it's a more reliable option. Transactional DQ-NQ is using the peak lock model in the scope of a transaction, and those transactions only span Service Bus. So we can't do, in Service Bus, we can't span Service Bus and SQL Server, for instance. You'll say, oh, that's terrible. Come to my session tomorrow. Queues is one of our features. They give you wonderful load leveling. Load leveling means the sender sends data in bursts. Once every hour, you get a burst of data. Well, what you could do is you could build out so much receive capacity that you can deal with that burst of data within that hour, within a very short time. And sometimes you have to, but if you get unpredictable load, if you get bursty load, then another thing you could do is put a queue in the middle. and then the receiver receives on its own pace. Take a message, work on it. Take the next message, work on it. Take the next message, work on it. You can never be stressed out in that way, right? It's like a public servant. The sender can never stress you out. Now, the wonderful thing is you can look at the length of the queue, the message count, and then add workers. Adding worker doesn't necessarily mean you deploy a new Azure role, but that probably just means you add another thread loop. So you can very nicely manage the load and level the load using queues. It also gives you a wonderful way to do offline and batching. Offline in the sense that if the receiver is not always available, it sits on a flaky network, maybe it's a mobile device, and you need to have a Dropbox for it, you can put that Dropbox into the cloud in Service Bus, and then the client gets the data as it is available, as it has network. And then batching also is good for cases where you're simply sending data into a queue. Our queues have a capacity of up to 5 gigabytes. You're sending that data into that queue, and then once a day, twice a day, you run a batch which basically drains the queue out, works on all that data, and then the batch process can shut down. So you only need to start that batch process once or twice a day if you don't need to have a report of the results more timely than that, which means that saves you money because you don't have to have that role deployed in Windows Azure all the time. What they also give you is wonderful load balancing. You have multiple senders, or you have a sender, and you have multiple receivers, so-called concurrent and competing consumers. Each consumer gets a message, works on it, gets a message, works on it, gets a message, works on it. You have N of those, because it's first come, first served. Whenever they show up, you go natural load balancing. It's not load balancing in the web way, where you have a web load balancer that just sprays load across a number of backends, irrespective of how loaded they really are. But here it's load sensitive. Everything that cannot be handled by those backends ends up as a backlog in the queue. So nobody gets overstressed. And you can always observe the message count to add more of those. So it gives you very natural, the best, the most efficient load balancing. Topics is another feature. So we were at queues. Topics are a supercharged queue, effectively. Topics are the same basic model. So there's a log, and they're exactly compatible with queues as far as NQ goes. It's exactly the same protocol. All the protocols that we support and will support. Today we support SBMP, which is our own protocol for our own clients. That's what the messaging API and the WCF API use. I'm going to talk about that towards the end. And we have an HTTP API, and we're going to add in the near future AMQP, the Advanced Message Queuing Protocol that we are developing together with a number of Wall Street firms and other infrastructure vendors. So we're in that AMQP consortium. We're contributing actively to it. And so we're going to add AMQP also as a way to talk to Service Bus. And with that, you'll also be able to use, for instance, natively GMS. We're testing against Apache Cupid. For instance, you can use natively JMS against Service Bus. So that protocol will be exactly the same. A topic is a message log, and a subscription is an independent cursor over that message log. When you think about how a queue works, a queue is a log that's just a chronology of events, right? So you add a message, the message gets timestamped. Next message, everything gets a timestamp and gets actually a sequence number that we put on it. Every message has a sequence number, starts at 1, and then for the duration, for the lifetime of the queue or of the topic, we add monotonically increasing numbers without gaps into that sequence. And so that sequence is ordered by those numbers. The queue has a cursor that goes over that log. And so as the receivers are getting messages, the cursor gets increased, and that's how the queue works. In the topics, same principle, but every subscription now has a cursor, which means every subscription has a shot to see every single message. So with the topic, each subscription can get each message, which gives you message distribution. So one message in, and messages out. You can also use constraint message distribution using filters, where you can go and put into the subscription a query onto the message, and only if that query matches the message, you will get that message. And that gives you very powerful ways of actually querying into a data stream or manipulating the data stream as you get it. And we're going to go into that in very deep detail tomorrow in the messaging deep dive session. The messages themselves in the broker look effectively like this. They're resembling roughly the HTTP frame. So we have key value pairs as on the frame effectively, lots of data, and we have a body that you can go and shape yourself that you serialize the data into. If you're familiar with, or if you're using SOAP, if you're using Windows Communication Foundation today, you will be very focused on putting data into the body. If you use the messaging API, what you will find yourself doing is to put a lot of the data into these properties. And that's because you get a lot of flexibility out of using those properties because of the filtering capabilities, because of the pub/sub capabilities. So when you start using Service Bus, you will actually find that the topics are much more interesting than the queues. We always get the question of, oh, so there are two queues in the Windows Azure platform, right? There's the Windows Azure queue, or Windows Azure Storage queue, and then it's the Service Bus queue. Which should I use? Well, if you look at them, they're fairly comparable. The Windows Azure Storage queue is only accessible through HTTP, and we have a host of additional protocols. If you look at it, we have actually a bunch more features. Again, tomorrow in that session, we're going to talk about a bunch of those features. But if you just need basic queuing, both are okay. What we believe is that actually the pub/sub features, that the topics is the thing that you really want to use, and that you would typically want to prefer a topic over a queue. In most cases, because one of the things you can do is you can always put an additional tab on it. So you have the main line, you have a topic, and you have a subscription. That looks like a queue. But if you want to, for diagnostics reason, know what messages are currently flowing, you put another subscription on it, and then you can get the additional messages out. So the messages look like this. So a SOAP message fits snugly into the body, and these are additional properties. What we see people do is ignore the body altogether and just put most data into the key value pairs, because that's just easier to handle. Also, because you can filter on them. So in each subscription, you can put up to 2,000 rules. It's crazy. But you can put up to 2,000 rules that have a condition and an action. If the condition matches, so let's say invoice total is greater than 10,000, or client rating is smaller than 3, then the message gets selected, and then you can also set a property on the message. Or the ship destination country. So this is for these two are, for instance, partitioning conditions, where you go and effectively partition out by subscription an audience by, let's say, last name. So if you want to build partitioning into a system, you can do range queries, you can do all those kinds of conditions for how you effectively partition out incoming data streams into different partitions and have then listeners onto those different subscriptions. You can also modify system properties here. So that's what's actually for those actions. So if you do, for instance, diagnostics, so you're running a diagnostic stream through a Service Bus topic, and you put the severity in here. Then you could say, if the severity is 1, most severe, set the TTL to the message to infinite. You want to see all those. If the severity is 3, the big chatter, set the TTL of that message to 5 minutes, so you only see the last 5 minutes and we're throwing away everything else. So you can actually manipulate the data stream as it goes through. There are 3 runtime API choices that you have, and then we're going to add more with the MQP protocol, obviously. You can use WCF if you're using that today. We have a net messaging binding that works roughly like the net MSMQ binding. Our team also owns MSMQ. Or you can use the messaging API that gives you all the features. I have an example of the messaging API in the following slide. And then you can also use the HTTP API. And with AMQP, you'll be able to use GMS. So that's roughly how it works. You have a namespace manager. On the namespace manager, you can go and create a queue. You can create a subscription. In the interest of time, because I still have a whole segment, I'm just going to show you the code. I'm not going to run it. So I have here are my namespace managers that I'm setting up. I can test whether a queue exists. I can create one. If a topic exists, I can go and create a topic. I can create subscriptions. So that's our management API. The namespace manager is the thing that manages the namespace. You don't have to explicitly create things on the relay because they're automatically created. But here you can effectively create your entities with that simple API. There's also some tooling that we have for download and as part of the SDK, which makes that a little easier. And obviously, you can also create those things on the portal, but that's the way how you programmatically do this. And this is how you can go and set the filters. And I have some more filters here. You can do a blind tap because you can manipulate those filters later. So you can set up a subscription and effectively set it in a way that you will never get any message for it. And then you can go later in and you can change the rule so that you then see the messages and you can turn it off again. And then we have a messaging factory. That's the one that dispenses all the runtime objects. And then you can create a queue client, and then into the queue client you can send. Obviously, you always use begin, send, and end send. This is just for show. And then send a brokered message. That's our message type called brokered message, where you can go and set the properties, and you can obviously also add a body. And we also have support for serialization here. And receiving is done this way. So it gives you natural direct access to the messaging API. Again, you can still use the WCF programming model. We have the net messaging binding, which gives you effectively all those features, including the pump, the receive pump, effectively for free. Lastly, how do you secure all this? So we have these keys that we're using, owner and some secret. What does that mean? Service Bus has a special relationship with ACS, with the access control service. It's also part of Windows Azure. So each Service Bus namespace has a body namespace in ACS. So Clemens v.servicebus.windows.net has a body namespace, Clemens v-sb.accesscontrol.windows.net. And they're pre-configured with a relying party for Service Bus. And they have a pre-configured service identity owner. So that's how we set this up. But you can go into ACS, and we have a tool that's part of the SDK in the authorization branch. So that's if you go and get the SDK samples and you look into scenarios authorization, you will find a library and a tool called the SBAZ tool. There's also a big README in it that allows you to create new identities and then also assign rights to them. And assigning those rights, you have 3 rights: send, listen, and manage, and that's it. If you have a send right, you can send into a relay endpoint, or you can send into a queue, you can send into a topic. If you have listen, you can listen on a relay endpoint, and you can get messages from a queue, and you can get messages from a subscription. And you have manage, you can create and delete stuff. Delete messages you can obviously do with listen, but delete queues and subscriptions, you need to have listen rights. That is all overlaid over the namespace. So the namespace is also our hierarchy for authorization. So the default is that you have owner, has send, listen, and manage. But you can now assign rights at every level of that namespace inside of ACS by creating a relying party definition underneath it. And the SBAZ tool is actually there to do that for you. So go into the SDK, get into the samples, and you can go and get that tool. And that makes it fairly simple to do that. I would show it, but I'm running out of time. So you can assign, for instance, Fred and Alice send rights and Peter listen rights on a particular entity, which means you can go and lock this down just to send and another party to receive. And that's something you cannot do, for instance, with the Windows Azure storage queues. So it gives you fully controllable fine-grained access control. So if you have, for instance, an application that sits on the phone, you can give that phone an account that you just make for that phone. And you can programmatically go and create those accounts, those service identities. You can create thousands of them. Just the right to send to a particular thing. And that's it. And then you have another part of your system which actually receives from them. So you can create fine-grained access control across the entire namespace, either over a namespace region, over a branch, or over a particular entity, down to the level, for instance, in topics of a subscription. So you can give on a subscription particular rights by just giving the rights on that particular branch, the particular portion of that namespace. And the way that's implemented is you have in ACS, you have these relying party definitions, and they have a set of rule groups, and those rule groups are then enabled. So you can actually go and, if you wanted to, you can go and revoke the rights for owner, the rights for the root on a particular entity. You could lock down an entity down to one particular party and not even have the root of the namespace, the root owner of the namespace, have access to that thing. And we're done. And I'm exactly landing on time. That's amazing. So I hope you have a good understanding now why we did this, or at least some beginning of an understanding, what the scenarios are there for. If you have questions, I think the best thing is to come up to me, because we're recording those sessions, so I don't want to make this all too long. And I'll also be available at the evening function, and so I'll be happy to answer any questions. Tomorrow at 12:30, we're going to do a deep dive where we're going to go in depth into the features specifically of messaging, and features like sessions and how you can actually go and triage the event stream, things like scheduled messaging, how you can use Service Bus as a timer, et cetera, et cetera. So if you want to come to that, then you're cordially invited. Thank you for your attention.